Hello, I'm Liao. Welcome back to Evan of Code. We are solving programming puzzles every day, and today we are on day 15. 1-5. So let's take a look at what is the challenge for day 15. So day 15, Lens Library. The newly focused parabolic reflector dish is sending out all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under the large sign that says Lava Production Facility, and then next to a smaller sign that says Danger, Personal Protective Equipment Required Beyond this point. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snout mark and a label "Push for Help." No wonder you were loaded into that trebuchet so quickly. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm, holiday ASCII string helper algorithm, is a way to turn any string of characters into a single number in the range of 0 to 255. To run the hash algorithm on a string, start with the current value of 0, then for each character in the string starting from the beginning. Determine the ASCII code for the current character of the string. Increase the current value by the ASCII code you just determined. Set the current value to itself, multiply by 17, and then set the current value to the remainder of dividing itself by 256. After the following steps of each character in the string in order, the current value is the output of the hash algorithm. So to find the result running the hash algorithm on the string hash, you do all the steps. Okay, I'm not gonna read through them, but I guess it's the same thing where you start with 0, add ASCII code, increase to, and then you multiply by 17, and then you modulus divide by 256 and get the remainder, and then move on to the next character A, S, and H. So the result of running the hash algorithm on the string of hash is 52. The initialization sequence, which is your puzzle input, is a comma separated list of steps to start the lava production facility. Ignore new line characters when passing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the results of running the hash algorithm on each site in the initialization sequence. So for example, this one, the initialization sequence specifies 11 individual steps. The results of the following running the hash algorithm on each of the steps is as follows. Right, so you do this and then you get all the numbers. And in this example, the sum of these results is 1,320. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. So run the hash algorithm on each step of the initialization sequence. What is the sum of the results? The initialization sequence is one long line. Be careful when copy pasting it. Okay, so we are going to write this. We're going to write code to solve this, right? We're going to implement the hash algorithm, and then we're going to calculate and we're going to sum the total of hashes for each of the instruction, and then that will be our results. So let's go to our code editor. So as you can see here, we have just finished day 14. We have all 14 days of code, and now we are going to day 15. And all this code is available on GitHub, and I've left the link to GitHub in the description below, so you can check them out. And let's get started. So first thing is I'm going to define the variable called input. And let me copy this example first. Let's solve the example and see whether we are on the right track. So for the example, so we need to implement the hash algorithm, right? So, and then this is a comma separated instruction, so we're going to split by comma. So input.split by comma. And then for each so we're going to loop through, right, instruction of this one. And we're gonna have our answer start with 0, and for every instruction we need to calculate the hash based on the instruction, and we're gonna add it to our answer, right? So the answer is the sum of the hash, and this will be and then we're gonna print out our answer, right? So this is the basic structure of our code, and now we're gonna implement the hash function. So for hash function, in string, we are starting with 0 as a result, and then we're going to loop through every character by character, right? So for let I equals 0, I less than string length I plus plus. So we're going to get the char code at the index I. So this is the ASCII code for the character at this index. So after we get this, basically what we need to do is we're going to add it in. We're going to increase the current value by the ASCII code just determined, right? So we're going to increase. So result plus equals to this one. And then we're going to multiply itself by 17. So result multiplies by 17. And then finally, we need to get the remainder. Itself is going to remainder of dividing by 256. So result is equals to results remainder of 256. And I guess that's it, right? So we're going to loop through every characters, and then finally this is the result. We're going to return from this function. We're going to sum it up, and that will be our final answer. So let's try and run our code. Node day 15. Puzzle 1, and we get 1320, which is exactly the same as what we have over here. So we're gonna get the actual puzzle input, which is, whoa, there's a lot. Let me copy this. Let's come back to our code over here. Let's paste this in, save, and let's run. And we get a number. I'm going to copy this. I'm going to paste it in. And then hit submit. And yes, that's the right answer. So we have solved part 1. And let's move on to part 2. So part 2. You convince that reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered from 0 to 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allows light to pass through from one box to the next all the way down the line. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus the light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Okay, along the wall running parallel to the boxes is a large library containing lenses organized by the focal length ranging from 1 through 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or HashMap for short. Each step begins with a sequence of letters that indicate the label of the lens on which the steps operates. The results of running the hash algorithm on the label indicates the correct box for that step. The label will immediately followed by a character that indicates the operation to perform, whether it's equal or minus. If the operation character is dash, go to the relevant box and remove the lens with the given label if it's present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. Filling any space made by removing. Okay. If no lens in the box have the given label, then nothing happens. In operation, if it's equal signs, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there is already a lens in a box with the same label, replace the old lens with a new lens. Remove the old lens and put a new lens in its place, not moving any other lenses in a box. If it's not already a lens in a box with the same label, add the lens to the box immediately behind the lenses already in the box. Don't move any other lens when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Okay, here is So here is the content of every box after each step in the initialization sequence above. So the first sequence is we have Rn equals 1. So so what does it mean? Okay, so it's box 0 after this one. Okay, so Rn1, let's see, what's the let me see. So label will be immediately following by a character that indicates the operation performed. Label, right? Each step begins a sequence of letters that indicate the label of the lens on which the step operates. Label of the lens which the step operates. The result of running the hash algorithm on a label indicates the correct box for that step. We have 255 box, and the results of running hash algorithm on the label indicates the correct box for that step. Label will immediately followed by a character that indicates the operation to perform. Okay, so if it's an equal sign, it will follow by the number indicating a focal length of the lens that needs to go into the relevant box. Be sure to use this label marker to mark the lens with the label given in the beginning. Label. So this is the focal length. This is the box. We're gonna put into. There's already a lens in the box with the same label. Replace the old lens with the new lens. I think this. So minus is removed, right? So we don't care. So this one we put. How do you know it's box 1? And then this one we're gonna go into box. This one is also box 0. Okay, is there an explanation? Okay, so all the 256 boxes are always present. Only the boxes that don't contain any lenses are shown here. Within each box, lenses are listed from front to back. From front to back, each lens is shown as its label and its focal length in square brackets. Okay. So I guess this is the label, this is the focal length. Okay. To confirm that all the lenses are installed correctly, add up the focusing power of all of the lenses. The focusing power of a single lens is the results of multiplying together. 1 plus the box number of the lens in the question. 1 plus the box number of lens in equation. So 1 plus the number of box plus the box number of the lens in question. Okay, so the slot number of focusing power is multiplied together, right? So one. Okay, so the box number plus 1, right? So 0 0 3 3 3, then it's plus 1. Okay, 1 1 4 4 4 multiplied by the slot number of the lens within the box. 1 for the first lens, 2 for the second lens, right? So 1 2 1 2 3, and the focal length of the lens. So this one is focal length is 1. We have 2, and then 4 9 5. Wait, 7 5 6. Okay, so we have this is the focusing power, and then we end up total focusing power is to sum them all of them up. With the help of the over enthusiastic reindeer in a hard hat, follow the initialization sequence. What is the focusing power of the resulting lens configuration? So let's see. How do you know which box it is meant to go into? I have still no idea, but I guess like once we decided QP, right, go to box 1, and then this one goes to box 0, and then if we have QP again, we're gonna remove it, right? Remove the QP. So now we're left with like this, and then if we have PC, we're gonna add it in. OT is at here. AB, we're gonna add AB. And then minus PC, so we remove it. So all this will shift front. PC we add again. So now we don't have PC, then we add at the back. And then OT replace, if it's OT the same, then we're going to replace it with 7. So this is a final arrangement, right, in order. And so for the which box should it goes to, let's see. I still don't get a bit. Each step begins the label with a sequence of letters that indicate the label of the lens which the step will create. The result of running the hash algorithm on the label indicates the correct box for that step. So I guess like if we run hash algorithm for Rn, then you get 0. Hopefully that's the case. Let me try and run and see whether it makes sense. So let me copy the code to step puzzle 2. Right? Let me first try and run the hash algorithm with QP. And see what do I get. So let me run day 15 puzzle 2. It's 1. Okay. So I guess that's why QP goes to box 1. Okay, now I understand it more now. So if I go with Rn, this goes to, okay, box 0. Okay. So now I understand very much easier now. Okay, so I guess now what we need to do is, this is our instruction, right? Let me copy back the instruction from the example, right? And then first thing is we're gonna execute the instructions, right? So for every instruction, we need to basically check whether it's it doesn't really say how long the character for instruction, right? It can be 3 characters, can be multiple characters, right? It's just whether it's with an equal or with a minus sign. So I guess let's use regular expressions to test this out. So I'm gonna have a regular expression that looks like this. Instruction dot match. We have some character. We're gonna start n here, and we have a few groups, right? 3 groups in exec. This one is optional. The first group is we're gonna have I guess any character here will do. Any character. And second group is either plus equals or minus. And then the third group is a it's a number, right? Because it's a focal length, it's a number. So I'm gonna say a dash any number over here. Right? So this is my capturing group. So I'm gonna have assume that this is always able to capture. I don't have to handle it. So I'm gonna destructure this. So for the first group is gonna be the label. Second group is the instruction. Operation. And then third is the focal length. Focal length. Right. Okay. So if the operation is equals to equal sign, then we do something. Else we do something else. Right? We could also write this as switch the operation. If the case is equal sign, we do something. And in case if it's negative sign, we do something else. Right? And default case, I guess we just ignore. So for either case, first thing is we need to find out the box we're gonna go to, right? So the box is basically box is equals to hash the label. Let's give us the box number. And after finding the box, we need to add or remove something from the box, right? So I think here we need to create the we're going to create all the boxes. So the boxes is equals to new array 256 boxes in total, right? Starting from 0 to 255. And each of them gonna fill by an empty array. So if we have equal sign, then which means we're gonna add the box in, right? We're gonna find so box is actually boxes of this index, right? We found the box index, and then this is the hash gives us the box index, and this gives us the box, and then the box will be an empty array. And then if we have a equal sign, we are going into finding. We're gonna go in the box to find a any item that has the same label, and if not, we're gonna find the label. We're gonna do something here. Right, we're gonna find something that has the same label, and then if we can't find it, then we're gonna add our box, add this current label in. So the label is gonna push this as an object. So with the label and the focal length is going to be I think this is make it a string, and then here we can have focal length as it's okay. I think let's skip it like this. It's okay because we don't have to do any operations for now. Just put it here like this, right? If we cannot find, I'm gonna push it in at the end of the array. But if we can find, then we need to basically find it and then update the focal length, right? Replace if we can't find items with the same label, we're gonna replace the focal length. So how do we find it? We are going to find this by okay, so I'm gonna say I'm gonna use a for loop to basically find all the items in the box start length. If box I dot label equals to my label, then box I dot focal length equals to my focal length. I'm gonna replace it, right? And in this case, I'm gonna break, and I'm gonna break out. Not I'm gonna break and continue to this outer loop, right? So I'm gonna say outer, or the instruction loop. I'm gonna continue this instruction loop, right? And if we able to reach here where we can't find labels that has the same label, then we're gonna basically we're gonna add this new label into the box like this. And for this one, for minus, what we're gonna do is we're gonna go through. We're gonna have the same loop iteration go through the array. Gonna find whether if I have the box the same label, and if we're able to find the box with the same label, we're gonna remove this, right? To remove it, I'm gonna do dot splice. Sorry, box dot splice I1. So splice is gonna remove one item from the array and then remove it, right? So the back of the array will shift forward, right? And remove one item from it. And I think that's it. And then we continue the instruction loop. And by the end of this whole instruction loop, we probably have all the boxes with all the have the boxes full with the lengths, right? And then next thing we need to do is we need to loop through the boxes for let I equals to 0, I minus boxes start length I plus plus. Right, so this is the box number, right? So we need to calculate the focusing power, right? So first is let's have a variable called answer equals to 0, and then finally we need answer, and focusing power equals to, first is we need the box number plus 1, so which is I plus 1, multiply by element in the slots, right? So boxes length, and then we need to loop through again. Let j equals slot number, I would say slot number equals to 0, slot number less than boxes plus length. So so the focusing power will be 1 plus I plus 1 multiplies by the slot number starts from 1, so it will be the again slot number multiplies by 1, sorry, plus 1, and then multiplies with the focal length. Right, so the focal length will be boxes I slot number dot focal length, and this is a string, so we're going to turn it into a number. It's like this. Okay, and then after that, we're going to add our focusing power into an answer. I'm going to sum it up, and then I'm going to print the answer, the final answer. So let's try and run this. And we get this number. It feels it's different. Okay, so something is wrong over here. So let's Let's take a one step back. Let's take a look at what happens at the end of instruction loop. Boxes, right? And let's print that out. And okay. So we all fill with the same array. That's why the all of the boxes looks the same, right? So I think this is not correct. So let's fill up with like maybe 0 first, and then map return a new array for every element, right? So this will return a new array for every element. Then let's try run this again. And then now every is 0. It's quite empty except the first few box have something. And we get 155, which is the same as the total focusing power over here. So I guess we are on the right track. So let me remove this and let me copy the actual inputs and try to run this with the actual inputs. Let's save, run, and we'll get a number. I'll copy this and come back, paste it in, and I hit submit. And yes, that's the right answer. So we got 2 more gold stars for today. This is day 15, and we have 10 more days to go. So we shall see you next day. Bye bye.